calculus, let's look at some examples of what we are starting in class. If we were asked to find the area under the curve f of x is equal to 4 minus x squared on the interval from 0 to 2, a good place to start would be to sketch this out. Make sure we know what this graph looks like. So I know it's a parabola. I know it's a parabola that has been shifted up 4 and reflected because I could rearrange it to look like that. So I know I'm going to open down, my y-axis is as high as 4. I also know just by doing a really quick solve, if I set this equal to 0, I know I'm going to hit the x-axis at 2 and negative 2, right? Move the 4 over, take the square root of both sides. Which means if I'm asked to find the area under the curve from 0 to 2, I'm looking to find this area right here. And we're actually not going to find the area in this video. We are simply going to write an expression that represents this area. So there's two ways we're going to do this. We're going to do it both with our summation notation and with our integral notation. I'm going to start with the one that I think is more challenging, which is the summation notation. To do this, we have to think again about our rectangles. So let's start. Let's start by deciding what is the width of each rectangle, delta x. We know it's b minus a over n, or in our case, starting and ending of our interval. So 2 minus 0 over n, 2 over n. Notice I'm keeping n because we want an infinite amount of rectangles, which is going to come into play with that limit notation at the end. Then I need to figure out what each value along this interval is, x sub k. This would be each step on the interval. Each step, x sub k. Well, it's equal to our starting point plus our change in x times however many things we have gone. So the first or the second or the third. Well, we're starting at 0. So in our case, x sub k is equal to 0 plus delta x, which we know is 2 over n times k. For example, if I'm looking at our first one, it would be 0 plus change in x, one copy of it, right, times 1. So our any step on this interval will be equal to 2k over n. This is helpful because we are able to get the height of our, the height of our rectangle by finding f of x sub k. Well, our function, f of x, is 4 minus x squared. So if I take x sub k, any step on the interval, and plug it into that, I would get 4 minus 2k over n quantity squared. And this is totally acceptable. Or you could take a moment and actually simplify that a little. 4 minus, I'm going to square all these pieces. 4k squared over n squared. Whichever way you want to write it is fine. And this is the height of our rectangle. Which means we are ready to write an expression that shows the sum of all of the areas of these rectangles. To do that, we are going to use our summation notation. We are summing up the height, 4 minus 4k squared over n squared times the width, 2 over n. We want to do this starting at 1, k equals 1 for our first step on the interval, and going to an infinite amount of rectangles, the limit as n approaches infinity. This is an expression that represents the area under the curve from 0 to 2. The other way we could write this is using our integral notation, which again I think is a little easier. We take this integral symbol and we add in our bounds. Where are we starting? We're starting at 0. Where are we ending? We're ending at 2. What function are we calculating the area under? 4 minus x squared, and this is with respect to x. These two statements are saying the exact same information. They're looking for the area under the curve of this function with respect to x. The next problem I want to look at It's actually a problem from the homework. Specifically, this is on the 6.3 circuit. 6.3 circuit. This is an example from the third page, page 3, and I think it is the top left problem. So they want us to now reverse the order. We're given this integral notation, and we need to figure out what would this look like as a limit. So let's notice a couple things. The first thing I notice is that we don't start at 0. We do not start at 0. That's important to pay attention to. The other thing is I know pretty quickly A and B. So my change in x, my delta x, would be b minus a divided by n. Or in our case, 7 minus 3 divided by n, or 4 over n. Next, we need to find each step on our interval, x sub k. But here's where we have to make sure we notice that we're not starting at 0. Any step on the interval is equal to a plus delta x times k. In our case, we're starting at 3 plus delta x, 4 over n times k. We need the step on the interval to give us the height. And notice this piece right here is our f of x, the function under which we're finding the area. So that means, let me make this look a little nicer, hold on.